Yeah. So we are going to do second derivative, find the turning points. Find the turning points are points. There could be more than one turning point or the following curves. And we have to explain whether it's a max point or a min point. So for turning point, we have to find the derivative and put it equal to 0. Remember, for example, in parabola, turning point is where the slope becomes 0. Slope becomes 0 means dy by dx is equal to 0. And then we find x. If we put dy by dx is equal to 0, we find x, and then correspondingly we can find y. There could be more than one turning points depending upon the roots of the derivative when we solve the derivative equations. Let's do few of the questions. So the very first one is this one, x square minus 4x plus 1. So y is equal to x square minus 4x plus 1. Calculating its derivative, that is slope or gradient, is easy. dy by dx, apply the power rule. So x square, derivative of x square is 2x. And derivative of minus 4x is minus 4. Plus 1, of course, is 0. So for turning point, this is a parabola, right? So its shape is like this. So it means at turning point, slope is equal to 0. So dy by dx, that is our slope, that is our gradient. This has to be 0. So dy by dx is equal to 0. That means 2x minus 4 is equal to 0. So we can find the value of x where our slope is 0, where it's our turning point. So this is going to be 4 over 2, x is equal to 2. So what is the value of y? In our first equation, y is equal to x square minus 4x plus 1, we put the value of x. So we will get y coordinate when x is equal to 2, where our slope is 0. So y at x is equal to 2, this value is 2 square minus 4 into 2 plus 1. So it's 4 minus 8 plus 1 minus 4 plus 1, we get minus 3. So turning point is 2 and 3. X is equal to 2, y is equal to 3. Fine. So whether it's maxima or minima, of course, it's parabola facing upwards, so it should be minima, but we have to do it analytically. So parabola, of course, if we know like it's parabola, so and it's facing upwards, so it is minima, right? But sometimes we have some complex functions, so we don't know whether it's facing upward or downward, or some complex function with high order, high value of x, so we don't know whether which part of it is max and which part of it's min. So we take the second derivative. Remember, second derivative, d square y by dx square, if it is positive, then this is a minimum point because slope is coming from negative, coming 0, and then slope is increasing. That could happen only when it is a minimum point. And if d square y by dx square is negative, then it's a max point because our slope is positive and becoming 0 and going negative. So this can only happen when we have a max point. For this particular question, if we want to find whether it's max or min, so we take the second derivative. Our dy by dx that we calculated is 2x minus 4. What should be the second derivative? D square y by dx square. This is how we write second derivative. So we have to take derivative of dy by dx. It means d by dx of dy by dx, which is 2x minus 4. So d by dx of 2x minus 4. So d by dx, derivative of 2x is 2 and derivative of 4 is 0. So we get just 2. No, 2 is positive. If 2 is positive, it means rate of change of derivative is positive. So it means it's going from negative towards positive. It's increasing. If it is increasing, so it means slope is increasing. So it means this is a minimum point. For minimum point, our slope is going from negative towards positive. So for this particular point, this turning point 2, 3 is a min point. This is good. So let's try to do some question in which we have power more than 2.
Wait, how did you get 2 from this?
So 2x minus 4. So derivative of 2x minus 4 is 2,
Yeah.
right? So we do some question in which power is more than 2. Let me do part I. Y is equal to minus x cubed plus 6x squared plus 3. So let me clean all the stuff over here. So I put like this. So this in I part, so this is a cube graph. So for cube graph, again, first thing we can immediately see it from its shape. So for the cube graph, I can draw the cube graph, but we will do it analytically as well. Cube graph is either like this or it's like this, depending upon what is the uh, x cube coefficient. If x cube coefficient A is negative, it start from positive and going at the end going towards negative. If A is positive, then it start from like on the left side it's going towards the negative side, on the right side it's going towards positive side. So this is for cube graph. Over here, what is given? Let me write down y is equal to this one we are doing minus x cube plus 6x square plus 3. The very first thing we have to find is turning point. For cube graph, there could be possibly two turning points. There could be only one turning point, but possibly maximum there could be two turning points. So dy by dx, take the derivative. So this is going to be minus 3x squared power rule. 6 into 2, 12 plus 12x. And derivative of 3 is, of course, 0. So we get minus 3x plus 12x. This is easy to solve. So there's no x term, so it just like minus 3x squared plus 12x. For turning point, we put derivative equal to 0. So dy by dx is equal to 0. So our slope minus 3x squared plus 12x is equal to 0. We can take x common. We get minus 3x plus 12. We could take 3x common, but okay, let's take x common. So now either x is 0 or minus 3x plus 12 is 0. So these are 2 points where we have got turning points. Let's solve this one. Minus 3x plus 12. So minus 3x is equal to minus 12. So x is going to be minus 12 over minus 3, which is 4. So we've got one turning point at x is equal to 0. The other turning point at x is equal to 4. We need to find corresponding values of y as well, so that we have coordinates of max point. And it could be min point or max point turning points. So when x is equal to 0, so y is equal to, just put x is equal to 0. So minus x cube plus 6x squared. So minus 0 cube plus 6, 0 squared plus 3. So y is equal to 3. Our turning point is 0, 3. I'm trying to save the space, so I've just put it here. For the second point, let me write down like this. So x is equal to 4, right? So y is equal to, this is going to be some big value. So minus 4 cube plus 6 times 4 squared plus 3. Minus 4 cube is 4 into 4, 16 into 4, minus 64. Plus 6 into 4 squares. So 4 square is 16 into 6, plus 96, and plus 3. So 9 is 96 plus 93 is 99 minus 64, we get 35. Wow, it's a big number. So we have got turning point and 4 is 35. When x is equal to 4, we got y is equal to 35. We have got two turning points. So 0, 3 and 435. So which point is max, which point is min? What we have to do is take the second derivative of this our given function, derivative of the derivative, and then we see at given point whether it is positive or it is negative. So let's take the second derivative. So d square y by dx square That means we are taking d by dx derivative of first derivative, which is minus 3x squared plus 12x. So this is minus 3x squared plus 12x. So it should be 2 into 3, apply the power rule, minus 6x plus 12. Okay. So we have got second derivative. So we have to check at x is equal to 0, whether it is positive or negative. So at first turning point, so d square y by dx square is equal to minus 6 into 0 plus 12. 6 into 0 is 0 plus 12. So 12 is positive. When second derivative is positive, it means rate of change of slope is positive. Slope of the slope, derivative of the slope is positive. So slope is from negative, it's going towards positive, it's increasing. So that means it should be a minimum point, min point. So 0, 3 is a min point. This is our first result. How about the other one? When x is equal to 4. So d square y by dx square at x is equal to 4 is minus 6 into 4 plus 12. So in the second derivative, we are putting x is equal to 4. Minus 6 into 4 is minus 24 plus 12. We got minus 12. Minus 12 is negative. So it means rate of change of slope, derivative of slope, derivative of the first derivative is negative. So slope of the curve is going from positive towards negative. It's decreasing. So this happen only when it's a max point. So it's something like this, max point. For min point, it was something like this. So slope from negative going towards positive. Over here, slope is positive, becomes 0 at turning point and going towards negative. Rate of change of slope is negative. So this is a max point. So we got our turning points, and whether these turning points are max or min, we have figured it out. So this is done. That was good. So we can do the next question. So using the turning points, I mean, all these questions are similar. So we go to the question number 2. Use the turning points you worked out in question 1 and what you already know about curved graph to sketch the graph in part M. M is this one. Y is equal to 2, x square minus 21x plus 72. So this is a cubic function. It's multiplied by x. So, and n, x square minus 3x. We can do one of those. So let's do part M. So I erase this to create some space and we do our part N. So we need to create, we have to sketch. So when we are going to sketch, first of all, we have to see its orientation. These are cubic graphs. So we have to see its orientation is from left to right or right to left, depending upon the coefficient of x cube. And after that, we have to find its y-intercept, possibly x-intercept, and then we have to find where are the minima and maxima. So let's see, y is equal to x 2x square minus 21x plus 72. I can keep it like this, or I can multiply inside. Let's multiply first. So we have two forms of cubic function. 2x cube minus 21x squared plus 72x. So for the shape or orientation of the function, we look at the head coefficient of x cube, which is we call a. A is equal to 2 is positive. If it is positive, so key function could be like this, it could be like this. When A is negative, its shape is like this. When A is positive, its shape is like this. So A is 2, it's positive, so it means its shape is going to be something like this. So now we have to find where does it intersect with x-axis and y-axis. So suppose, I don't know where will it be, suppose it's like this. Somewhere it intersect y-axis. So it could be on the right, left, up, down, and just like making a general graph. So if we have to find out its y-intercept, so we have to put x is equal to 0. So I write down y-intercept. So far we have figured it out, its orientation. For y-intercept, put x is equal to 0. So it's all going to be 0 because x is 0. So 0 is multiplied by everything is 0, or put 0 over here. So it's going to be 0. It means it's going to pass through the origin. So 2 into 0 cube minus 21 0 square plus 72 0. I'll just put in the first equation x into all this becomes 0 because x is 0. Why is 0? So it means our graph is going to pass through somewhere like this. It could be something like this, or it could be something like this. But it has to pass through origin. The y-intercept is at 0. So this is, we have got some idea of the graph. So where does it cut x-axis? So x-axis means x-intercept. So for x-intercept, we put y equal to 0. For x-intercept, y is equal to 0. So in our main equation, we can put it equal to 0. So x 2x square minus 21x plus 72 is equal to 0. So either x is equal to 0. So of course, y it is passing through origin, so it will intercept at x is equal to 0. What are the two other intercepts? So we put 2x square minus 21x plus 72 equal to 0. We can factorize it, or we can solve it using quadratic formula. So I'm just using quadratic formula. So x is equal to minus b plus minus b square minus 4ac under root divided by 2a. So minus b, so over here you can see like a is equal to 2, b is equal to minus 21, c is equal to 72. So we need to prepare our calculators. So minus b is going to be minus 21 plus minus b square. So 21 square square of 21 is 441. Let me do calculation. So we got and then we have to do minus 4ac. So 21 square is 441. That's true. And minus 4ac. So 4 into 2 into 72. 72 times 8. So we got 72 times 8 is 576. So we are not going to have x-intercept any other point. So this is possible. So 21 plus minus, we got something negative number. 441 minus 576 divided by 2
AC.
4 AC
Wait, but wasn't the
divided by 2
this was 2AC?
divided by 2a. So
Oh, so-
divided by 2 into 2, 4. But that doesn't matter because we have got our discriminant negative. So there is means no real roots. So it's not going to intersect x-axis at any point. So what we have got over here is just something like this. This is quite possible. Our cubic graph could be something like this. So how about or it could be something like I can draw like it could be yeah. So it means these where we have got our dy by dx is equal to 0, those are like inflection points. Those are not minimum or maximum point, those are inflection points, right? So this is we have drawn our function like this.
So then how is it supposed to look like if it doesn't intercept X?
So it's just intercepting x-axis at origin.
Oh, okay.
So
wait, but the X intercept is 0,
yeah, so at 0 it cross from origin.
but it's not real.
No, one root is 0.
Oh yeah, right.
It could have possibly three
Yeah.
roots, but it could have one root or two roots or three roots. Remember, for QP function, it crosses x-axis at least one point, or it could cross at 2 points or 3 points.
So here we're just checking if it has any other.
Yeah, exactly. Whether we have. So if we have got real roots, we will compute. We can do n part. Let's see in nth part n. So if we can have more roots. So I erase this one. We can do part n and try to sketch that graph. Let's do part n. So y is equal to x squared minus 3x. So in part n, we have got y is equal to x squared minus 3 minus x. So x squared and then 3 minus x. We know like now x is going to be 0 or x is equal to 3. So those are its x-intercept. Let's go step by step. So first we expand it. We got 3x squared minus x cubed. So coefficient of x cube is -1. So it is -1, which is less than 0. So its shape is going to be like this, from starting from left as positive and going on the right as negative. So remember, if x is positive, it's something like this. If a is negative, it's something like this. So we are in this case. 3x square minus x cube, we can take its derivative to find where our point of inflection or where our minimum and maximum point. So dy by dx is, so 3x square minus x cube, apply power rule. So 6x minus 3x square. So this is derivative. We can take, suppose you can 3x as common, so we get 2 minus x. And we can put it equal to 0 to find where are the turning points. So it means x is equal to 0 is turning point and x is equal to 2 also a turning point. We have got two turning points. That was quite straightforward. We don't have to go for quadratic formula. So there are two turning points at x is equal to 0 and x is equal to 2. So we have to check which one is minima and which one is maxima. Uh, First we try to sketch it and then we find out which one is minimum and maximum. We already know like its shape is going from, because its head coefficient, x cube coefficient is negative, so it's going from left towards right. And now its turning points are at x is equal to 0 and x is equal to 2. From the shape, we know like first is going to be minimum and second is maxima. But it could be point of inflection as well. In that case, it's not min or max. What is y-intercept? So y-intercept is again 0. Y-intercept when x is equal to 0. So x squared minus 3x. So if we put x as 0, so this y is 0. So it will pass through origin, right? So it is going to pass through origin. How about x-intercept? So we put y is equal to 0 for x-intercept. X-intercept. So y is equal to 0. X squared and 3 minus x is equal to 0. So x is equal to 0, we already know. And 3 minus x is equal to 0. So it means x is equal to 3 is an other point where we have to cross x-axis. So over there, what is the value of y is equal to 0? So this is 3, 0 and 0, 0, right? Two intercept points. So so the shape is something like this. It's going like this, and then it go up and then go like that. something like this. So it's like one min point is touching and this zero, and then max point is up and it's over here. So we have to figure it out. Although we know like first point is min point and next point is max, but we can do our analysis. Take the second derivative, d square y by dx square, right? Derivative of our derivative, d by dx of the derivative. Derivative is 6x minus 3x square. So derivative of 6x minus 3x square is 6 minus 6x. 6x, derivative of 6x is 6. Minus 3x square, so 2 into 3, 6. We have got minus 6x. Whether this is positive or negative, we're at our turning points. So when x is equal to 0, so d square y by dx square at x is equal to 0 is 6 minus 6 into 0 is equal to 6. So this is positive. If second derivative is positive, so this is our min point. We already know like this is going to be a min point. So when second derivative is negative, in that case it will be max. So let's see, when x is equal to 2, this our second turning point. So d square y by dx square is equal to 6 minus 6 into 2. 6 minus 12, which is minus 6, which is negative. So if it is negative, it means slope is going from positive to negative. Slope is decreasing, so it has to be max point. So how is the shape of graph? Actually, we have already drawn it. So I draw it again. Just I draw over here. I erase.
Wait, how do you get this x is equal to 0?
So when we have got first derivative, we put first derivative equal to 0, right?
Yeah.
So if first derivative is 0, so we get values of x. So 6x minus 3x square, I took like 3x common and 2 minus x, put it equal to 0, right? So 3x is equal to 0 means x is equal to 0. This is first turning point.
Oh, yeah.
2 minus x is equal to 0, so x is equal to 2. This is second turning point.
Yeah.
So let's sketch the graph. I make a canvas over here and we can sketch the graph. Final point for this. So we have got our axis, make it tidy axis, x-axis, y-axis. It has to pass through the origin, and the first point is our minimum point. So it will pass through this, right? It is y-intercept as well, and it's x-intercept as well. And this is our minimum point. And then at x is equal to 2, we have got y is equal to something. But we should actually calculate when x is equal to 2. So 3 minus 2 is 1 and 2 square is 4. So it has to be 4. Over here is 4. It's 4. So it is max, and then it goes and cross at x is equal to 3. That was our intercept. So that was our sketch of the graph, cubic graph, right? So this is how we find the second derivative. First derivative tells us where are our turning points. Second derivative tells us whether the turning point is maxima or minima. And then we learn like how to draw cubic graph using the coefficient of x cube, finding the derivatives to find turning points, where are y-intercept, where are x-intercept, and which turning point is minimum and which turning point is maximum. Thank you.